mechanical machines and how they work, and what's the product of putting work into an actual machine, seeing what we get out of, if it's efficient or not, and yeah, just things like that. There's a few things that we'll have to understand to sacrifice distance to get more force, to apply more force onto an object. Specifically, we can look at here, there's going to be an actual mechanical advantage. We can see that by seeing the force that we get out of it over the force that we put in it. What does that mean? Imagine a screwdriver and you're trying to pry two boards apart. You put the screwdriver in between the two boards, you're going to apply a little bit of force that will then turn into a great amount of force at the tip of the screwdriver that helps pry open the two boards apart. That is one idea for seeing actual mechanical advantages. Looking at the ideal mechanical advantage, we can use the same analogy with the screwdriver. We're going to be looking at DE over DR. What's DE over DR? DE is going to be the distance that you have to move your screwdriver down in order to pry apart the wood. DR, resistance, will be how much the wood would actually spread apart. Like I said, we can look at it on the AMA, where how much force is needed to see how much force is going to get out. Then also we can look at the IMA, which deals with distances and how much we move something will open up something else. Also, we have the relation, we know work equals force times the distance, and with these two new things that we just introduced, the IMA and AMA, we can then form an equation such as this, where the force in times the DE equals the force out times DR. And just to make things a little bit more simple, the force in can just be simply put as FE, and the force out can be put as FR. With this, we can then find the actual efficiency of our system. Now, the systems that we have will never ever exceed 100%. It's against the laws of physics. The efficiency will be under 100%. A way that you know that you've done it mathematically correct is your AMA value should always be lower than your IMA value. Reason why your AMA value is going to be lower is because here our AMA is dealing with forces, and with forces there is also this force called frictional force. Work can get lost through friction, work can get lost through heat, so there's always going to be some type of loss in the system that will make the system not 100%, but just a little bit lower. So for the first part, we're going to be messing with an inclined plane. We'll get a cart and fill it with some mass, and this mass will be given to you. The weight down here is going to be our effort. So the effort is going to be changing. We're going to be changing the incline from 15 degrees to 30 degrees to 45 degrees. And when we change the incline, we'll have to add weight or take away weight, you'll see, in order to get a constant speed for this cart. So right now, I have it set between 20 and 15 degrees, and I want to see a constant speed, so I have some grams loaded onto my weight, my hanger, and I'm going to let go of my cart and hope to see a constant speed. And so that was nearly constant, which with the nearly constant speed, we should have a uniform acceleration. So we want to do that for 3 different angles. Our length is going to be measured from this black hash to this hash here. So the constant speed only needs to happen between this distance here. Using the equations from your lab book, you'll be able to find your IMA and your AMA, and with those two, you'll be able to find your efficiency of each angle. And You'll be able to find which angle is actually the most efficient angle. So the second part of the experiment, we're going to be dealing with 4 different pulley systems. Each pulley will have an increased pulley. So we'll start off with 1, we'll move to 2, move to 3, and then finally 4 pulleys. You'll notice as you increase the amount of pulleys that you'll see a trend in your efficiency when you're using it to calculate. We need to make sure that our weights are in equilibrium. So our resistance, which will be under all the pulleys, will hold 500 grams plus the hanger, which equals out to 550 grams. And then we need to balance the system. We now have our system balanced, and to make sure it's balanced, just the bottom of the hangers need to be flush with each other. And now we get our effort, and then we make a displacement of 10 centimeters. So from where it is here, it's approximately at 106 centimeters. And so I'm just going to grab the effort and pull it down to 96 centimeters. And my resistance was originally at 106. So now we want to see how much it was raised. And it seems it was raised about 3 centimeters from its original position. Once you find how much the resistance was raised, record that, and it'll help you with finding the AMA, IMA, and later the efficiency of each system.